Find the domain of the function f of x equals the square root of x squared minus 25. We know that the square root of a negative number does not make sense. That is, whatever goes underneath the square root need to be either 0 or positive. In mathematical expression, this means whatever under the square root has to be greater than or equal to 0. We can only take the square root of 0 or a positive number. We're looking for the domain of the function, meaning we're looking for the x values, but the condition in this case is x squared minus 25 greater than or equal to 0. So we need to isolate x, meaning that we have to solve these inequalities. To do that, first, from algebra, we know that we can factor this difference of two squares. 25 is 5 squared. So on the left-hand side, we can rewrite it as x minus 5 times x plus 5. And we want this product to be 0 or positive. Now, there are many ways to solve this inequality. One straightforward way to solve this inequality is to pretend that this is equal to 0. So first, we solve x minus 5 times x plus 5 equal to 0 to find any critical numbers. Now, this product is 0 only if each of the factor is 0 itself. This is because of the zero product property. This product is 0 when either x equals 5 or x equals negative 5. And so these are the two numbers that we are interested in on the number line, which is the set of all real numbers. There are two solutions in this case. There are two numbers, 5 and negative 5. And since there are two numbers, these two numbers divide the whole number line into 3 pieces. We just simply need to pick a number from each piece to check to see if it satisfies the inequality. Any arbitrary number in each of the pieces would work. We know what happened when we plug in negative 5 and 5. It would make the inequality equal to 0. So we can use negative 5 in the domain, and we can also use 5 in the domain as well, because the two numbers would make the expression x squared minus 25 equal to 0, and the square root of 0 is 0. It makes sense. But what about these numbers in each of these pieces? Again, pick any arbitrary number in each piece. So in this interval, I'm going to pick the number on the left-hand side of negative 5. You can pick negative 6, negative 7, any number, negative 100 even. If I plug in x equals negative 6 into the inequality, I see that x minus 5 times x plus 5 becomes negative 6 minus 5 times negative 6 plus 5, which is negative 11 times negative 1, which is positive 11. What that means is that any number we pick from this piece, when we plug them into this inequality, it will make the whole expression positive, which is good because we want the expression to be positive. Similarly, we would pick another number in the second piece. Any number between negative 5 and 5 would work. It is easy if we pick simply 0. Now, when x equals to 0, plug in 0 into x. We have 0 minus 5 times 0 plus 5, which is a negative number times a positive number, which we know that is negative. Notice that we do not need to know what the exact value is. We just need to know whether it is positive or negative. And lastly, we're going to pick a number in the last piece. Why don't we just simply pick 6 or 7 or even 1000? 7 minus 5 times 7 plus 5, which is a positive, times a positive, which is still a positive number. And again, to evaluate the expression, we just simply replace the number into the placeholder. With the last piece, we know that it is positive. And so the domain of this function is any number between negative infinity and negative 5. Any number between negative infinity and negative 5 would make the expression underneath the square root positive, and also any number between 5 and infinity. Now, in mathematics, we express this as interval notation, so the answer is negative infinity to negative 5. We open the parentheses for negative infinity and we close the brackets for negative 5 because we want to include negative 5. And we combine this or union this. This symbol looks like a capital U, 5 to infinity.